When a good can be consumed by only a single individual at a time, it is called a private good. But when a good, like fireworks, can be enjoyed by many individuals at the same time, it's called a public good. So far, we've dealt only with private goods. In Chapter 14, we saw how to add up demand curves from individuals for private goods to form the market demand curve for private goods. We'll now ask how to form the market or aggregate demand curve for public goods. These too will come from individual demand curves, but they'll be added up differently because of the different nature of the good. When the good X on the horizontal axis is a private good, then we add demand curves horizontally in order to derive the aggregate demand curve. In this case, the aggregate demand is shaped only by the magenta individual's demand curve if price is above 90. But for prices below 90, both individuals demand the good X, and so the quantity that's demanded is the horizontal sum of their demands. You can review the logic behind this horizontal addition of demand curves in graph 14.1, panel A. Individual demand curves for public goods are derived in exactly the same way as individual demand curves for private goods. Both emerge from the consumer's optimization problem, where the consumer at different prices tries to do the best she can given her circumstances. In panel B of the graph, we draw two such individual demand curves for the public good Y on the horizontal axis. From here on out, it'll be most intuitive to think of these as also representing those individuals' marginal willingness to pay curves, and thus implicitly assuming the absence of income effects. For quantities above 90 on the horizontal axis, the only individual who gets any benefit from the additional public good that's being produced is the magenta individual 1. Thus, the total marginal benefit for goods above 90 is determined solely by individual 1. For quantities below 90, however, both individuals get some marginal benefit from each unit of the public good that is being produced. For the 80th unit, for instance, the green individual 2 gets a marginal benefit of 10, and the magenta individual 1 gets a marginal benefit of 20. For the 60th good, both individuals get a marginal benefit of 30, and for the 40th good, the magenta individual 1 gets a marginal benefit of 40, and the green individual 2 gets a marginal benefit of 50. Adding these marginal benefits for the two individuals then gives us the total marginal benefit of each of the units of public good that are being produced. Adding the marginal benefit of 10 that the green consumer is getting for the 80th unit to the marginal benefit of 20 that the magenta consumer is getting for the 80th unit, then gives us an overall marginal benefit of 30 for the 80th unit. Summing the two marginal benefits of 30 for the 60th unit gives us an overall marginal benefit of 60 on the blue aggregate demand curve. And adding the marginal benefit of 40 that the magenta individual 1 gets for the 40th unit to the marginal benefit of 50 that the green individual gets for that unit gives us an overall marginal benefit of 90 for the 40th unit of the public good. In panel A, we can see that adding demand curves to arrive at the market demand curve for private goods implies a horizontal addition of these demand curves, whereas adding individual marginal benefit or demand curves for public goods to get an aggregate demand or an aggregate marginal benefit curve for public goods implies a vertical addition of the individual curves. We can then get an initial hint as to how the efficiency condition differs across private and public goods. In the case of private goods, if the marginal cost of producing the private good X is 40, the efficiency condition says that individual 1 should consume 40 units of the good, and individual 2 should consume 50 units of the good. In other words, the individuals will consume until their marginal benefit is equal to the marginal cost of producing the private good. The efficiency condition for public goods, on the other hand, will be a little different. Suppose the marginal cost of producing the public good Y in panel B is 60. We should then produce until the marginal cost is equal to the total marginal benefit, which is measured on the blue aggregate demand curve. Thus we should produce 60 units of the public good. The efficiency condition in panel B is then that we should produce until marginal cost is equal to the sum of the marginal benefits that individuals get. Whereas in panel A, the efficiency condition said that we should produce until the marginal cost is equal to each individual's marginal benefit. This should make intuitive sense. In the private good case, the total marginal benefit of a unit of output is equal to the private marginal benefit of the consumer who consumes that good, and so we should produce until the marginal cost is equal to each consumer's marginal benefit. But in the public goods case, the total marginal benefit of a unit of output is the sum of the marginal benefits that each of the consumers receives, because multiple consumers can consume the same good. Thus we should produce until the marginal cost is equal to the sum of the marginal benefits that the individuals who consume the good get.